So hey guys, so like what I said in the previous video that I will add a generator to the turbine. So I added one, a generator with no core. It's shaped like flower with only one coil. It's called Serpentine coil, and we use magnet with 3D printed rotor that hopefully is strong enough to handle the RPM. And we add some circuit and sensor to read the voltage and current. In this video, we will test the turbine RPM with generator added and how much power it can generate. First, I designed the stator, rotor, and mounting base for bearing and adding space between turbine rotor and stator to not wrap each other when spins. This is the design when assembled minus the shaft. So I 3D printed the rotor and mounting base for bearing, and I installed the magnet with alternating pole, north-south, north-south. I'm using pattern magnet with a diameter of 10 mm and 4 mm thick. For the coil, I'm using Serpentine coil that easy to make because only need one coil. So I just need to wind the coil once. It's so practical and simple. Because I want the generator to generate some voltage above 10 volts. I guessing to make it around 120 turn and using 0.2 mm copper wire or 32 AWG. First, I designed the stator and 3D print to make the coil hold in place. I using a super glue, and there you go. You have a serpentine coil. The turbine rotor and stator sandwiched together with one shaft using a longer M8 bolt. Second, I added bridge rectifier and 220 microfarad 25 volts electrolyte capacitor to make AC current from generator to a decent DC current that easier to measure. And the load I using a 3 watts 12 volts LED. For the voltage and current sensor I using INA 219. It's pretty accurate and easy to connect to Arduino using a I2C protocol. The Vin plus connected to voltage output from bridge rectifier, and Vin minus connected to positive of LED. We will test it 2 times. The first test, I open the blow gun slowly to read the increase in RPM and the voltage. The voltage gradually increases as the RPM increases. The maximum RPM for the first test is around 4200 RPM. We take the last peak and generates 14.8 volt and around 211 milliamps of current and 3.1 watts of power. Same power as the LED rated, so maybe we need more load. The second test, still the same setup. In this test, I can push it to 4,400 RPM with the same air pressure, just adjusting the position of the blow gun nozzle a little bit. It can generate 15.2 volts and the same current around 211 milliamps and the power around 3.2 watts. The cable covers the power reading since this turbine cause a lot of vibration due to the shaft and bearing being little loose, I suspect. That make the cable vibrate and move, but nonetheless it can generate a decent electricity. Happy with that. The space between rotor and stator quite wide, around 2 millimeters. Maybe I can make it to around 1 millimeter to make it more efficient, but 2 millimeters seems good enough since the results are pretty good. Added weight from rotor makes the turbine RPM decreases, but nonetheless with 4,000 RPM it can generate more than 3 watts of power. Maybe I think I need to change my load to a bigger one. Well, that's for the later video. Conclusion from this video: the RPM decreases because the added weight from the rotor and eddy current from the coil, despite it pretty small. Well, the load at the moment just 3 watts. It generates a small eddy current. The turbine slows down from 6,000 RPM with no load from previous video to around 4,000 RPM with added rotor weight and 3 watts of load. For the efficiency, I am not measured it yet because I think it needs a bigger load to get the maximum power out of the generator. So maybe in the later video I will change the load and calculate the efficiency of the turbine. What do you think of this project? Tell me in the comment and don't forget to like and subscribe. And if you want more video like this, you can support me through Patreon. You can get my 3D model of any project. Thanks for watching. Bye.